Okay, so then what does that mean for this worksheet, right? So this is kind of a series of different experiments that scientists have done looking at kind of the roles of auxin. So one thing they do is they put a little cap, aluminum cap, on the top of a growing stem, okay? And they're shining unilateral light, so the light only shines from this direction. And then they wait some time. So what'll happen here is, you know, the apical meristem is up in here, so it'll still produce auxin. So auxin's being produced, but absent that light source, because of the cap that's over it, you know, inside here, the auxin is diffusing pretty equally, right? So what's happening is all the cells on both sides are elongating more or less the same. So the plant is growing bigger, the cells are growing bigger, making the plant grow up towards a non-existent light, right? So this would be the same equivalent as if the light was shining right above the plant. It would grow that way. Absence of light just causes it to diffuse. Here, you know, light, it moves away from the light, so it's still going to move down, but so it just grows that way. In this case, where light's just shining this way, the auxin moves towards the dark side, right? So it's all going to accumulate over here, and only the cells here are going to elongate, and that's going to cause that whole plant to bend this way. All right. So, you know, that's the most basic experiment, and actually Darwin was one of the first ones to kind of do some of this. Now, some more advanced ideas here. So here we put a mica sheet. So this is impermeable to auxin. So the auxin can't go through. So you shine a light this way, right? Now what should happen there is the auxin should accumulate all on this side and then accumulate down like that, right? But what happens is it just accumulates to there. So actually you still get straight growth because it can't actually elongate the cells here, so it doesn't bend towards the light like it's supposed to. Okay. However, if we put the mica sheet on the opposite side here, nothing really happens because remember the light's coming this way, so all the auxin diffuses towards the dark side here. But that mica sheet is on the light side, so it doesn't matter. The plant doesn't care there, so we know it diffuses down that way. So these cells elongate on the dark side, pushing the auxin that way. All right. So some other variations here. So here we cut off the stem, and then we put a piece of gelatin through it. Now, gelatin, the important part here, it allows the diffusion of auxin. Okay. So nothing changes here. The auxin diffuses on the dark side, and the plant still bends towards the light, which again is shining from this direction, right? So on all these, just remember the light's shining from this direction. So in this case, issue one is it's in the dark, so no light, and we just cut off the tip and we just scooted it over a little bit. So in this case, the plant will grow this way, okay? Why does it grow that way? Well, so there's all this auxin up here, but the only spot it can diffuse down is just this half side of it, right? So what that causes is all that auxin there causes these cells to elongate, pushing it that way. All right, so I hope these kind of make sense. And really the key here is where's the light and where does that push the auxin? Wherever it pushes the auxin, that's going to cause the elongation, okay?